All right, so our last video, Exponentials video 3, is looking at dividing monomials. So to divide monomials, you're going to use the quotient rule. So when they have the same base, that's the most important thing. You can only divide them when they have the same base. You subtract your exponent, so it becomes x, a minus b. So I told you PEMDAS would come back. You take care of your parentheses, okay? You can take care of them by multiplying. When you multiply your exponents, you actually add them. You keep the base and you add the exponents. When you divide exponents, you keep the base and subtract your exponents. So looking at number 1, we have x to the 5th over x to the 3rd. So what we're going to do is x to the 5 minus 3. So when you subtract 5 minus 3, you get that the answer is x squared. We'll look at this second one. You have k to the 12, k to the 2. When you subtract, you get 12 minus 2. So that means you have k to the 10. So looking at number 3. 3 over 3, it's going to be m to the 3 minus 3. You get m to the 0. Well, remember, if it's a 0, it goes to 1, so your answer is actually 1. Let's look at number 5. Or actually, let's look at number 6 because they get a little trickier. We have, I'm going to write down here so we can see x to the 20 minus 5. We have y to the 9 minus 9. And we have z, that one's supposed to be a 1, 2 minus 1. So when we simplify 20 minus 5, we have that it is x to the 15. 9 minus 9 means we have y to the 0. Z, 2 minus 1 means that we have z to the 1. So when we simplify, your to the 0 goes to 1. So we actually end up with x to the 15, z. That's your answer for that one. Okay, so we know what to do when there's just variables. But let's look when there's examples with coefficients. So here's your steps. You divide the coefficients and then simplify the variables with the quotient rule. So looking at number 7, you're going to do just like it shows. 6 divided by 2. 6 over 2 is 3. And then you do x to the 4 minus 3. When you do that, you get that it is x to the 1 power. Even when it's a negative. So you do negative 15 divided by negative 3. That gives you a positive 5. So then you subtract. X to the 6 minus 5 is 1. Y to the 5 minus 3 is 2. And then you're just left with your z. Okay? Keep in mind the mixed practice, the PEMDAS. Let's look at 14. We'll go ahead and do this one as well. Because if you look, actually, let's do number 13. You have to follow PEMDAS, right? And I said you have to take care of the parentheses with the exponents. So looking up top, I have 3x to the 5th. So what this looks like is I have 3x to the 5 times 3x to the 5 times 3x to the 5 divided by 27x to the 3rd. So but before we can divide, we have to take care of the multiplying, just like PEMDAS says. Okay, so remember your PEMDAS, you don't have to write it. I'm writing it because you can't see it from above. You have to take care of your parentheses, then you have to multiply. So we have 3 times 3 is 9, times 3 is, we get 27 on top. And then you have to take care of 5 plus 5 plus 5 is 15 divided by 27x to the 3rd. Now you can multiply, you can divide. You divide your leading coefficients. 27 divided by 27 is 1. And you end up with x to the 15 minus 3, which means you get x to the 12.